So anyways, I'm Dan Massey. This is joint work along with Randy Bush and a number of other people that make up a DARPA project on essentially infrastructure protection. And what we're interested here in doing is talking about the routes leading to top-level servers. In particular, we all know we have a critical point of failure near the 13 root and 13 GTLD servers. GTLDs are covering the ComNet and org. And if you were to lose all the 13 root servers, we've all heard, network will fall away and bad things will happen. But there really is a potential here for a disproportionately large impact of a fault if, say, 13 bogus routes deny you access to the root servers, or even with one bogus route, since we don't have any kind of authentication inside the DNS, if I can trick you into believing a false root server or a false COM server, I can do a substantial amount of damage. So there's sort of a high risk for this attack. We're only looking at the very top of the tree because as you move lower in the tree, we have sort of a natural defensive scale. You certainly can take out somebody's servers. Just the absolute sheer number of servers makes the problem less interesting and not less interesting to the site being attacked, but less interesting to the global network. And of course, the scale is somewhat limited there. All right, so we actually have a lot of ongoing measurement, and I'm sure everyone knows in your BGP routing table, you have some routes that got there by misconfigurations, possibly attacks, some kind of errors. There's a little bit of FUD floating around there. And these, of course, can include the prefixes that reach GTLD and root servers. And just to give you an example that this really does happen, the CGTLD usually sits over 192.26.92.30. And we noticed one day that prefix seemed to have moved to a small ISP in Europe. And filter lists ideally would have caught some stuff here. This wasn't the only route that snuck out. But it did go out to the general network. And from where we were sitting at our monitoring point, 4 of the 9 ISPs we were watching adopted this route. 3 of those ISPs held on to the route and continued to announce it to us for about 20 minutes. One ISP held on to it and announced it for 3 hours. And then eventually it was actually killed at the source, never reappeared, and nothing, never to be seen again. And of course, this isn't the only example, but we all know bad routes escape out there, and sometimes they hit servers. The ISP in question here wasn't trying to imitate a C-root server, but you could imagine if somebody was, you can sort of direct a denial of service or maybe direct a redirection of traffic attack against some number of ISPs. How well you can control how far that spreads is an interesting question, but certainly it's a possibility. All right, so we have kind of an interesting idea for a solution here. Current BGP provides dynamic routes, which is certainly a good thing, right? And here we are coming with Randy and myself and a bunch of academic people saying, hey, wait, let's look again at dynamic routes. So what we're doing is actually trying the opposite extreme, just to see what happens. So what we're going to do is we're going to say, select a single route to each one of the servers. So we're going to put in there 25 fixed routes. We use AS path filters to make sure that's the only advertisement we're going to accept. So when that route is gone, we can't reach the server. We're also, of course, going to apply more specifics so that you can't sneak a more specific route in to get around our filter. And this route is going to change on a frequency of months, if at all. So we're not going to try to accommodate link failures. We're not going to try to do any kind of engineering, traffic engineering. The only time we're going to change is if a root server IP address changes. So, not frequently. Or possibly maybe an origin AS changes, or we see some real legitimate change in transit policy that we were forced to adopt to. And we're only going to adjust to this new route after we do offline verification. Right. So essentially we're static routing to 26 servers. All right, so why is this even something you could consider in theory? Well, there's a couple unique features here that we're looking at. First, the scale of the problem is limited to a small number of routes. We're looking at 25 routes. So there are 26 servers, but one shares a prefix. So we have 25 total routes. And we have no problem of exponential growth. If you count the total number of top-level servers, even including things other than ComNet and org, you still have a relatively small set. And it's not growing, or not growing fast, at least. We also believe that it's okay to actually lose one of the routes to the servers for a while. It's actually much better to have a lost route than a route pointing you to an invalid server. And we all know DNS will deal with the loss of a few servers. It's going to time out. It's going to retry whatever survives. And as long as we provide that the surviving servers are able to handle the load, and maybe we're willing to pay a little cost and delay on timeouts, the DNS is still going to work. We also claim that we believe there are some predictable properties here. These servers don't change without non-trivial effort. Right? This is not a web server hanging off somebody's DSL modem at home. This is a root server that you're going to have to talk to ICANN to move, and it's fixed. Also, we believe these sit in places that have highly available locations, and part of the ability to run a root or GTLD is hopefully you have the ability to keep your network up, a substantial amount of the time, right? Or possibly you shouldn't be running a root server. So in theory, we believe maybe it's a good idea, but of course, the only way you ever really find out is you have to look at some actual data. And so what we did is we took an analysis of BGP updates using the RIPE data set. I think everybody's probably heard of RIPE. If you haven't, basically we have an archive of all BGP updates sent by a number of peers. We're in particular looking at nine ISPs, US, Europe, and Japan, a variety of qualities for the ISPs. The data we use goes from February of 2001 to April of 2002. Also, a couple data collection notes. Now, we only use peers. We restricted our results to peers that exchange full routing tables. So we're not losing any dynamics because somebody's export policy is hiding a route. And also, one unique feature of a lot of the monitoring points is they use multi-hop BGP to connect a remote router to the monitoring point peer. And basically, that's really pretty much unique to the monitoring infrastructure. And those peering sessions do tend to reset a little more frequently than would happen in a real ISP. So we try to discount a little bit for session restarts where the session goes down, same routes get re-advertised as the session immediately comes back up. I would hope you don't see that in your operational networks. If you have your peer on a direct link and you're frequently seeing a session restart, you may have more concerns. Okay, so some actual numbers here. This is taken from a typical ISP in our study. It's a US, it's a tier 1, although as I understand everyone here is a tier 1. So the top line counts the number of servers you can reach and the percentage of time they're available. So if you look at the red here, this ISP is able to reach 13 of the servers about 98% of the time. Right? And if you want to reach 11 of the servers, you pretty much have 100% of the time where you can get to 11 servers. And so that's good. Now you apply our filter, and you are going to lose some routes because remember we're restricting you to specific static routes. So your route goes away, no backups are available. So the number of times you can reach 13 servers drops dramatically. So you're down to 75% of the time you get all 13 servers. But as you get up to certainly 10 servers, the results with and without the filter are pretty much indistinguishable. 10 servers with the filter, I'm still reaching all of them. Without the filter, I'm still reaching all of them. The difference, of course, is I'm going to ignore any bogus routes that are sitting out there when I apply the filter. So I've actually gained something, and I'm going to try to claim that I haven't really paid a big penalty in terms of what I've lost. Now, when I say static routes, I mean how static is static, right? Things do change in the network, and so over our 14-month period, for example, if you look at the A root server, we had to do 3 manual changes to the filter. We had 2 actual valid changes in Origin AS and a few other non-valid, but the 2 were really actual occurrences. On May 19th, the Origin AS changed from 6245 to 11840. Origin AS changed again on 6401. And if you look those up, those all belong to the organization you would expect. So these are legitimate changes. We also saw 1 change in a transit AS routing policy that caused our filter to reject routes. And that's where somebody stopped prepending his AS number. So 10913 was prepending its AS. It stopped doing that. In hindsight, perhaps our filter could have been a little smarter to allow that. So that I'm not sure that's really a static change versus maybe an oversight in filtering. But of course, we did lose something. So what really got lost? So if you look at the data set from the beginning of the study until that first AS change where we switched paths, our filter reduced the reachability to the A server from 99.997 to 99.904. We actually saw 18 events where the trusted route got lost and was withdrawn. 2 of these events resulted in ISP1 actually losing connectivity to the server. So we had one event where 28 seconds of no route, one event of 103 seconds of no route. Now, interestingly, we only had 8 instances where we used the backup route that survived for more than 3 minutes. And 3 minutes is a somewhat magical number we took from some work by Craig, and sort of as what's a possible point for saying this is maybe a legitimate change versus this is not. And of all the backup routes we used, the longest backup route we had stayed around for 15 minutes. So that was probably a legitimate route. The rest of these changes, you may have been okay actually throwing them away. And these results, we have 9 ISPs and 26 servers, so I can present these graphs all day, but this is essentially a representative one. And on our website and on a paper, you're welcome to look at more data. So just to give you sort of an example of what got filtered out. So here's one event. We initially start with, this is our trusted route to the A root server. And I'm only showing the tail of the AS path. Trusted route gets withdrawn and replaced by this guy at 1606. Now our filter would have dropped this, but the ISP is still claiming I can reach the server. We lost an AS there, but about 30 seconds later, we had another path change, and yet another path change, and then finally we declare no route, right? So this is not unexpected in BGP. I mean, people who've looked at BGP convergence aren't going to be too shocked by this result. And if we had applied the filter, all those would have been thrown out. And instead of declaring I have no route at 1608.30, I would have declared I have no route at 1606.32. And, so in this case, throwing that away maybe is not such a bad thing to do. I'm not sure how much reachability you really had in that interval. So even though our graph looked pretty good, I'm going to claim that the results are even better if you consider when the route really gets you to the server. Of course, there's always a worst case. And so of the 9, this is the worst case in our study. And here you can see a drop in root server reachability that I think is actually worth thinking about and is a little bit worrying if you're this ISP. So initially, this ISP, 99% of the time, you have 13 servers. You apply our filter, and you only get 12 servers 60% of the time. So 40% of the time, you've lost at least 1 or 2 servers. And we only start to catch up with the real routing around 6 servers. And you only need 1, assuming not everybody switches to the same one. So, the ISP would still work, but still, the other graph looked a lot nicer. So where did this leave us? This left us with, all right, we don't actually want to come to NANOG and put static routes in your backbone. That's not really what the point of the talk is here. But we do think that, there may be a balance to look at here. And some problems with our approach are we did require infrequent updates to the filter. And this would have been especially useful to automate because I think there's a natural tendency that if it's a task that must be done and is done sort of periodically, there tends to be a tendency to either forget the task or when it comes up, forget what were the steps I did to update the filter. So it'd be nice to either update the filter frequently or automate it. Right? Also, if we allowed more than one path, obviously we improved robustness. Our simple filter allowed only one path, got pretty good reachability. We could have improved that ISP3 graph tremendously if we had said, let's allow 2 paths into our filter, because that ISP was sort of often switching between a main path and a well-used backup. So really the question here is, can you strike a balance between simply accepting any route through a root server that someone advertises and the other extreme of saying, I will only follow this known valid route to the server? And of course we have a claim that we have an algorithm to do that. And so the main idea behind the algorithm is just to sort of slow down the dynamics and add some optional verification depending on how secure you want to be. So we apply some hysteresis before accepting a new path. So essentially the dynamics for these routes are actually slower than what you would get in the real internet. And if you want, you can throw in an optional module here to either believe the route simply because it survived in the table a while, use some probabilistic query and response to make sure what you're getting back from the server really is a real answer, or maybe trigger some offline checking. For instance, the AS of the root server has moved. Let's ask the administrator if that makes sense, and maybe even mail mark at VeriSign or post on NANOG, did the root server really change? And if you want the details of the algorithm, you can get those in a paper on our website, and I'll have a reference at the end here. But so what happens if you sort of try to strike this balance between adaptivity and static routes? And so this is ISP1, and I think we've done a pretty good job of improving overall reachability. We're still getting 97-ish% reachability to 13 servers, and even at 12 servers, the difference I think is negligible, and a lot of that loss is routes that you wouldn't have used to get to the server anyways. You look at the GTLDs, a similar story. What's more encouraging is this was our worst case, and it still is our worst case. And for ISP3, by just allowing a little bit of adaptation, we're able to still protect against the forged route, or the misconfigured route, but we still have high degree of reachability. Same story for the root servers, for the GTLD servers. And so it's really a fairly simple story, but I think hopefully an interesting one. So our conclusions basically are that, look, we've been looking at data from a research perspective. We're interested both in securing BGP and securing DNS for however you might define securing. And here's sort of a unique special case where maybe you really can do something. And we did observe faults in the internet. We think there is a potential for denial of service, so we would encourage people to at least watch this and see if you are believing bogus routes to top-level servers. And be worried that if you do believe 13 bogus routes, and you probably have 13 bogus routes in your table now, the wrong 13 and you're in trouble. And we propose a solution here of sort of the counterintuitive thing. Maybe dynamic routes aren't all they're cracked up to be. I mean, but certainly we want some dynamic adaptation to topology changes, ability to use backup routes, but let's consider making these less dynamic. This is clearly limited to this problem. We're not going out there and saying, let's put a static route for the entire table, right? This relies on the unique properties of the root servers, in particular scale, ability to lose one, and the belief that these are at highly predictable and stable locations. And we will lose some robustness to failure. So certainly anybody considering doing this needs to look at your own topology and make sure you have disjoint enough paths so that if you are going to filter, you allow yourself enough robustness so that one link won't cut all 13 root servers. You fall over to backup paths which aren't allowed in your filter. But for the most part, our data shows you won't be in that case. And you will gain some protection against invalid routes. And then also what we had hoped is maybe some feedback from the general audience on what is essentially the merit of the problem. There's lots of concern over the general problem of security for BGP and DNS. Do people really think this is an issue? And we'd be welcome for feedback. And certainly restrict this to the special case. We have filter. It's academic research, so it's publicly available. It does not run on your router. Well, it can run on your router, but it doesn't have to. Essentially builds a filter on time parameters you control. I want to let routes change on the order of hours, weeks, months. You can tune the parameters. And also, if you feel we're totally out of the water here, the data we have says it seems to work. So we'd be very interested in any data you can give that would give us a counterexample. And that's pretty much it. Questions?
Stephen Stewart today. I think I'll be F-root. I have two questions. One, what's up with ISP3? I mean, did they suck, or is somebody doing the bad thing to them?
Well, I think ISP3 suffers from two problems. First, I told you that two servers sit on the same prefix, right? And they have trouble with that particular route, so they pay a little extra penalty there. And for that route, essentially what they're doing is, I think it's too short-term to be traffic engineering, but they occasionally do lose their primary route. And when that happens, they fall over pretty much immediately to a backup route that'll stay around for an hour or 2 hours until the primary comes back.
Okay. When you say they lose their primary route, is that a function of losing their primary provider? Or is just that route getting withdrawn?
That route getting withdrawn from the, we're trying to have some discussions with them. We don't really have a good explanation from them as to why that is going away, but it is periodically going away and trying a backup path.
Okay. Question number two is, how much does your data change if you start locking down the AS path from one end and increasing by one?
Right.
That's locking down the entire path. What if you start from the the known origin of the prefix and work your way that way? And conversely, what if you start with what you know to be your best next hop AS and work that way?
Okay, I think there's actually two interesting things there. One, I mean, there may be sort of a cause and effect here that if people really did this, we would see a much greater change in the dynamic of the root servers, which could in turn change the results from our study.
More porn faster, absolutely.
Yeah. But I think, basically, we've looked at that. I don't have good data on that right now. What we can do is we can say, based solely on what I know about my routes, all I can do is just choose my paths. This is what I select, and if I do it, I get this result. We hope to have more data in that direction, but I don't have something for you now.
If you're going to follow up, that would be interesting to know.
Okay, yeah.
Cool, thanks.
What time period would you like to have these filters work on? I mean, are you looking for mechanisms? What sort of time ratio would you like these filters to exist on?
Well, we believe we have a pretty good, based on the ISP data we have, we believe we have a pretty good trade-off, and our current trade-off allows a route to change at most once a week. And if you allow that, you're getting reasonable answers.
Okay.
But I think it also can depend on your particular spot in the topology. Randy.
Yeah, that I think is the strongest answer, Sue, is it depends upon what your fan out is, right? What your upstream fan outs are, where you are in the topology. If I'm sitting, the extreme case, of course, is if I'm sitting there with one upstream, I listen, I believe.
Thanks.